Hello, my name is Carsten Friberg. I'm the Executive Director of IPHA. I would like to welcome all to this IPHA webinar. It's the third webinar in what is a long series of webinars. In the webinars, we invite 3 of our member companies to present a company webinar of 15 to 20 minutes duration, showing innovations and developments which could be of interest to our members. In this webinar, I'm very happy to welcome Elematic, StruSoft, and MBCC. I hope that you will all find it interesting and useful to see these presentations, the presentations which follow. I'll now leave it to IPHA's webmaster, Tom Goosey, to conduct this event. Thank you very much.
Thank you, Carsten. Good morning, everybody, and good afternoon to those of you joining us from a bit further east. I'm the webmaster for today, so what I'll do is just give you a brief overview, if you haven't used GoToWebinar before, of how things work. Obviously, those of you who were here last time, you'll know what you're doing in your way around. So before I introduce our first presenter, just to let you know, we have a chat box. Your webcam's still on, Carsten.
Oh, sorry.
And microphone. Thank you. Cheers. So yeah, on the right hand side, we've got a chat box, and if you want to send any messages, you can type into there. You can also ask questions of any of our presenters, so they're going to have roughly 20 minutes each, but we will leave some time at the end of each presentation for questions. So if you look on the right hand side, as I said, there's a small tab called questions. You can type them into there. I'll receive them, and then at the end of their presentation, if we've got time, I'll pass those questions on to our presenters. So that's it, really. I hope you enjoy the webinar, and I'll introduce our first speaker, who is Jani Eilola. Jani is Product Director, Floor Technologies at Elematic. Jani's going to talk to us about the factors that make a Hollowcore factory more competitive and how you might improve them. So there we go, Jani.
Okay, hello everybody. I'm very excited to see you all here. Long time no see with many of you, and my subject is how to improve competitiveness in Hollowcore factory, and of course you are the experts in this subject. You know maybe 10 times more than us, but hopefully Elematic as a machine producer can bring interesting ideas into the table. So hopefully you can see my screen now. Can Tom confirm if my screen is visible?
Yes, we can, Jani.
Okay, so let's move forward. So I will first be talking about the competitiveness in a little bit general level, and I have divided into 6 different sections: product portfolio, costs, which affects the price you are able to give to your customer, and quality, delivery time, reliability, and sustainability, very important nowadays. And after that, I will talk about ways to improve the competitiveness, and I will focus in 4 areas: material costs, how to reduce material cost, labor cost, and how to increase capacity and uptime, and of course conclusion will follow in the end. So competitiveness, if you think about the Hollowcore factory, of course the most visible thing for the end customer is the product portfolio, the Hollowcore slab, of course, but what kind of cross section you are offering to your customers and how well they meet the market demand, that affects how competitive you are. If your slab are let's say too heavy or too light, then you will have a challenges. So you want to meet these load bearing demands what your customers have as well as possible. And then, of course, the modification you offer to make to your customer affects your competitiveness. What kind of openings you allow, what kind of longitudinal cuts, crosswise grooves, what kind of accessories you will put into the slabs, weld plates, fixing loops, and of course one thing which would make your product competitive is to use lifting insert for easy lifting. And then the second area is quality, and of course the standard set the minimum quality what your hollow cores need to fulfill, and that's the minimum level, and then it's a question if your customer is willing to pay more of a higher quality. In example, the planarity of top surface, which would reduce the amount of screed needed. So if your customer is willing to pay that, so you could be making a little bit higher quality slab to get a little bit better price, and that way improve your income, but also your competitiveness in the field. And anyway, the quality of the slabs affects your image. Then delivery time and reliability. So one way to look at it is optimizing the factory capacity to market demand. So how to handle the issue in the fluctuation in the demand for the slabs. So that means that you need to think about if you want to run your factory 100% capacity, or if you would and then use the size of the storage and delivery time to flex because of the fluctuation in the demand. But the alternative consideration is that if you would make your factory a little bit higher capacity, so that you would run a little bit less than 100% capacity, so that you would have an extra capacity in case your delivery time would be getting too long. And then the question is, what are the overheads? The lower they are, the lower is the effect of having that extra capacity. And the overheads consist of, for example, personal costs and financial costs. And that means that by maximizing the automation level, your running personal costs would be lower, and the effect of having extra capacity would be lower. And also if you are able to have extra capacity with low investment, that would mean that your financial cost to keep that reserve capacity would be lower. And of course, it's a balance between efficiency and delivery time. The closer to 100% you run, the more efficient you are, but the less flexible you probably are with the delivery time. So that was one part of the consideration. Then other part is that it's not only a balance, but you need to be able to make valid estimations. And that means that you need to offer your capacity more than once, because not every offer will bring you an order. At least that's typically the case. And that means that there is a risk that the good thing happens and you have a positive problem, and you are getting, let's say, too many orders. But that means that you need to be able to have as good forecast as possible for the coming orders, and that's possible to handle with the softwares. Then sustainability has been becoming more and more important, and during 1 and 2 years it's really become an issue, and also for the precast industry. And of course the basic fact in our industry is that the cement producers have the critical role, because the 95% of the CO2 emissions of a Hollowcore factory comes from the cement. So it's up to the cement producers to find out the low CO2 to cement, and that's what they are doing. And of course, precast factory, even if it can only affect quite a little, but still we are talking about thousands of tons annually which you can save. And the most important thing is to reduce the amount of cement, because at the moment it's causing CO2 emissions, so the less you are using, the better. Then recycling waste concrete is an important way of reducing CO2 emissions, and that you can do directly with modifiers, so you can recycle the fresh concrete back to extruder and reduce your concrete consumption. And also, of course, you can crush, and many of you are crushing the waste pieces and using it as an aggregate. Then you need to heat the bed and the production hall. In Finland, we have a -15 at the moment, so I think the factories are heating quite much at the moment. And of course, the lower the CO2 emissions from the heat sources, the less is your emissions. So by using natural gas, district heating or heat pumps, you can lower your CO2 emissions from heating, and of course by using renewable electricity, you can also reduce the carbon footprint. But the precast business and concrete business has been the climate criminal, at least if you look at the media, what they are saying, that the timber is excellent and concrete is bad. But there is a really bright news for us, because there are research being made and development happening, and the CO2 curing is studied, and if you combine CO2 neutral cement, which could be in the case if and there are already cement factories who have this kind of a carbon capture and sequestration system, where they capture the carbon and pump it to the old oil wells, for example, so that the cement is CO2 neutral. And by using CO2 curing, where you put the CO2 back to precast products, and that's only possible in precast production. So by using those two, precast products could be turned into a carbon sink, and that, I think that's an amazing thing, and that would mean that we as a precast industry could be also an important part in lowering the CO2 emissions, and that's really turning the tables around 180 degrees, and the precast concrete would turn from climate criminal to some kind of a climate saint or something like that. So I think that's a really exciting and positive news. But of course, we are talking about future things. These will probably come after 5 or 10 years, but hopefully soon. But that was a really positive news I wanted to talk to you about. And but then I will go to the ways to improve competitiveness, and there are two methods, let's say 2 ways, and you can improve your competitiveness by your price competitiveness by lowering your unit costs, and that's possible by minimizing your total costs, and but on the other hand, you can do that also by maximizing the capacity. So the total costs are over the line, and total production square meters are below. So that way you can, by minimizing cost and maximizing your production, you can minimize your unit cost and be more competitive. And what does it mean to minimize costs? There are, of course, the biggest part are the material cost and personnel cost. And material cost you can lower by reducing your cement content in your concrete, by reducing concrete consumption and reducing waste and rejects. And the personnel costs you can, of course, lower by increasing automation level, but also the trained, skilled and motivated workers are efficient and make your production more efficient. Then maximizing the capacity reduces the cost as we saw, and when you are keeping the number of personnel the same and the invested capital the same, or keep the increase into minimum. But now I will go still a little bit deeper to the production, how to minimize the production costs. So biggest possible contribution is to have, for example, Elematic extruders, which have extremely high compaction performance, and that way there is less space between aggregate particles, and that means that you need less cement water paste to glue these aggregate particles together. And that way you can have as little as 285 kilograms per cubic meter without other pozzolans, or there are a couple of factories who have been able to go down to 225 kilos in cubic meter by using fly ash. And that way you could save, in an example, 300,000 euros per year when producing 300 square meters a year. Then one other part was the labor cost, which you can of course lower and minimize by using automatic machines, and Elematic has been putting a lot of effort and resources in making our product portfolio automatic, and now we can offer you automatic patching and mixing plant, automatic concrete transportation, bundles, quick bundle stressing with Stressor E9, automatic extruders, modifier, plotter, looper, automatic saw, high power preparer E9. So we have this kind of tools for you available, which you can use to increase your efficiency. So only the lifting of slabs and machines and preparation are completely manual, but mechanized phases, and of course maintenance and some additional tasks, in example putting plug stacks, so on, are still manual. But there are a lot of tools now available for increasing the automation level. And we already saw that with the extruders you can minimize the cement content, but then on the automation side, if we are looking at the one machine which can provide the biggest leap in automation level, that's surely the modifier E9, and it can automatically dig openings, plot and drill weep holes, and that way reduce the needed manpower by 2 to 3 persons, and depending on your labor cost, that could mean 300,000 euros a year when producing 200,000 square meters. And in addition to that, it can also recycle the concrete back to extruder E9 and P7, and that way you can save 1 to 3% of concrete or even more, and that could mean up to 60,000 euros a year if you are saving 3% and producing 200,000 square meters a year. But it's not only about machines, but also when you have automatic machines, the more important it becomes that you have a good software to do the production planning and control your production process and monitor how you are doing. And with FlowMesh, you can fill the bed as full as possible, minimize overstranding, and optimize your production plans on multiple variables. In example, based on the erection order of the slabs, the difficulty level, and of course stranding and so on. So that was about minimizing cost, and now we talk about maximizing output. And of course, the key part in maximizing output is the casting machine, and with the Elematic extruder E9, you can cast up to 70% faster and up to 7 meters per minute, and that means that in case you would be casting 6 beds with regular speed, so with the fast speed you could reach 8 to 10 beds per day, or 18, even 18 beds per day if you would be casting in 2 shifts. And that's possible with new machine design and new automatic compaction control algorithm and separate screw drives. And what are the benefits of a high capacity? It's that the production hall can be smaller, the smaller investment needed for same output, the same number of workers, but higher capacity. And because of a smaller production hall, you would need smaller, less expensive cranes, small plot of land and foundation. So this taking everything out of your production line, it brings lot of consequential benefits also. So it's not that there are only consequential damages, but there can be also consequential benefits, and that's the case here. And of course, that means when you are able to maximize your capacity, means that you can also maximize your return on investment. And I promised to show you a video of extruder E9 casting with high speed, and in this video you can see it casting 5-core 400 millimeter slab with a 2.3 meters per minute. So 2.7 is possible up to 320, but also with 400 millimeter slab we can cast very high with very high speed. So the stripes are 10 centimeters, so you can see that the casting is happening very fast, and the slab quality is okay. And of course, we have measured, and our customers have measured the strength of the slab, and we still have very high strength with that speed. So I hope that's interesting for you. And so the extruder and the high casting speed is the core of the maximizing capacity. But again, as with the maximizing the automation level, also maximizing the output, there the production planning system is also in key role. And with the flawless manufacturing execution system, you can do difficulty-based variable scheduling for your daily workflow, and that way optimize the daily working hours so that you are doing as much as possible and using all the hours efficiently. And then the fourth part in fourth way in improving your competitiveness was increasing your uptime. So of course, only producing factory is productive. It doesn't matter how high is your capacity if your factory is not running. So you need to have reliable equipment, and that you can have by doing preventive maintenance and the fact that these machines record the running hours, that makes it easy for you to do preventive maintenance when you know how much you are running. Then when you have a problems, it's very important that there is somebody who you can call if you cannot solve the problem by yourself. So Elematic has help desk available where you can call in case of problem, and we can do then remote troubleshooting from Finland, or send our service engineers to your factory in case of a more difficult issue. And of course, the spare parts are also in key role in having the uptime up. So we have over 3,000 items in stock and available to be shipped in very short notice. And also tens of customers have made maintenance agreement with Elematic, where we agree about the discounts from spare parts, and also there are regular service engineer visits included, which means that our service engineers come to your factory and check that everything is operating efficiently. So as a conclusion, we have developed tools for you to increase the Hollowcore competitiveness, and that means that those tools are automatic machines, software, the high casting speed, and extensive services which we have available. And in IPHA, we say the common interest, the success of Hollowcore is the success of every one of us. And as a last thing I want to say that let's take more market from cast in situ and other competing solutions. So thank you, and now I could take questions if any arises.
Thank you. Thank you, Jani. We don't have any questions from the audience, and as we are running just a little bit behind schedule, I'll move on to the next presentation if that's okay with you. But
okay.
But thank you very much for that interesting presentation. So yeah, just to introduce our next speaker to you. So that's going to be Gaetano Guarino, and Gaetano is the customer segment manager for manufactured concrete products Europe at Master Builders Solutions, which is MBCC-Group. And Gaetano is going to talk to you about a newly developed product called MasterEase Technology and how that's applied to Hollowcore production. And he's also going to talk about low viscosity concrete and the benefits that that can provide to you. So if your microphone's on, Gaetano, can you? No, we can't hear you yet, Gaetano. Is your microphone on?
So sorry, Tom. Thanks a lot for your kind introduction, and good morning to all of you, of course. I hope that you can see my screen and that you can hear me well. So,
yeah, that's all fine.
Okay, thanks. So before starting, I would like just to spend a couple of additional words about myself, since I am new here in the association. So I am a chemist as a background, and I have joined the company in 2012. That was previously BASF and currently MBCC-Group. But anyway, I will tell you something more about that in a while. And what I can say, after more or less 8 years spent in the European R&D group, I moved in April last year to the European marketing team. And as already said by Tom, I currently cover the position of customer segment manager for manufactured concrete products. I have replaced my colleague Nicoletta Zeminian in this position, since she is now taking care of the ready mix and site mix market segments. And of course, I believe that most of you may know Nicoletta quite well. And my wish is also to have the chance to meet you face to face soon, in order to establish, of course, also a kind of personal relation that is always good to have. Well, let's start. Here you can see the agenda of my today presentation. So, as anticipated, let me briefly introduce our new company, the MBCC-Group. And then I will go through the technical details of the presentation, showing you the performance of the newly developed MasterEase technology. So the MBCC-Group has recently emerged from the former BASF construction chemical business after its acquisition by Lone Star Funds. The carve-out process from BASF was successfully completed in 18 months, and we started to operate as a standalone organization in October 2020. MBCC-Group can be considered as one of the leading suppliers of construction chemicals and solutions worldwide. Indeed, we are operating in over 60 countries among the globe, with more than 120 manufacturing sites and around 7,500 employees. Of course, we have already tried to deliver, I would say, this message through different channels like our website, the social media, press releases in specialized magazines. But I would take really the chance today to underline this again, also into the IPHA community. Anyway, I will stop here. I will not go too much into the detail because my idea was just to give you a quick overview about the new company. But of course, if you want to learn more about the MBCC Group, you can just follow us on the social media, or you can click and visit our new website. So I will now move into the technical part of my presentation, talking about MasterEase. The brand MasterEase represents our latest generation of polymers. This is a patented technology that is unique to us, and it is based on really new molecules that allow to provide superior rheological properties to the fresh concrete. And if I have to think about the potential application of this technology into the Hollowcore field, the production by using slip formers seems to fit, I would say, quite well here. As you know very well, I would say, this type of machines need the really specific concrete characteristic to operate properly, like, for instance, high cement content or high water to cement ratio, especially if we compare them to extruders. And this means that the rheology, or let's call it plasticity, of the concrete plays a quite important role in the production process with the slip formers. And additionally, I would say, to be really fully honest with you, chemical admixtures that are commonly used in the production of Hollowcore with slip formers are usually based on quite old technologies. Don't get me wrong, because anyway they are useful, but this kind of admixture just help really the machine to run easier and faster, because they are able to reduce the friction among the concrete particles, and therefore increasing in some way the compaction of the elements. But I would say, on the other hand, they usually don't allow to optimize the mix design. So if we need to compare Hollowcore production with, for instance, standard prefabrication, what I can say is that really the highest benefit of chemistry may come through the water reduction approach, as it is in the case of standard prefabrication, because water reduction allows to achieve higher strengths, and so to reduce the cement content, bringing to, I would say, economy and sustainability as well. But what is also true is that in the case of the Hollowcore, the mix design optimization through the water reduction approach is often not possible by using the conventional polycarboxylate ethers or PCE-based product, like in the prefabrication, because after the reduction of the water with PCE superplasticizer, the Hollowcore concrete tends to be too sticky, and this doesn't allow the machine to run smoothly. So MasterEase, because of its special properties, can really represent here a valid alternative to common admixtures, since, in my view, it's really able to fill this gap, allowing also the Hollowcore producer to optimize in the proper way the mix design. So before going into the real life and showing you a couple of field trials that were carried out in the production plant, I would present a few preliminary tests that were run in the lab to validate the MasterEase technology. So what we have available in the lab is this production efficiency method. And to explain a bit better to you, this production efficiency method is a test method that allows us to simulate in the lab, until a certain extent, of course, the production process of dry and semi-dry concrete elements. In the production efficiency method, I will take also maybe the pointer here. Yeah, in the production efficiency method, the concrete, the dry concrete, is compacted in a gyratory press here by the pressure applied by a piston that is accompanied by a constant speed rotational movement of this cylindrical mold, according also to a certain angle of inclination. And the pressure applied and the cylinder's rotation angular speed are parameters that can be changed as required and have characteristics values according to the production process that we would like to replicate. For instance, they can vary if we want to simulate the production of paving stones or blocks, or for instance, Hollowcore, and so on. So in the PEM test, the number of cycles that is needed to achieve the target density can be really considered proportional to the compaction or extrusion energy exerted by the machine in the plant. And on top of that, the cylindrical specimens that you can see here, that we can obtain after the compaction, present exactly the same final density, and so they can be used for the evaluation of the strength development of the elements. So I will present you here an example of the test, and in the table on the bottom part of the slide here, and also in the graph on the top right, you can see three different tests. The reference is highlighted in blue, while test number 1 with the master cast product based on old technology is in gray. And finally, we have the test number 2 with MasterEase that is reported in orange. And as you can see in the test number 1 with the master cast, it's not really possible to optimize the mix design because we kept the same amount of cement and the same amount of water if compared to the reference mix. Anyway, what you can observe in test number 1, if you compare it to test number to the reference, I would say, is that the number of cycles needed to achieve the target density of 2,400 kg per cubic meter is significantly lower. We have 20 cycles for the test with the master cast versus the 32 cycles of the reference without admixtures. And this behavior underlines exactly the easier compactability of the concrete treated with the master cast. In the test number 2, the one with the MasterEase, it's possible to go, I would say, a step ahead if compared to the test 1 with the pure master cast. Indeed, if you look here at the numbers, MasterEase allows also to optimize the mix design on top of the compactability improvement that was achieved with the master cast. And in this specific case, we have reduced by 30 kg per cubic the cement content, and by 12 liters per cubic the water content, in order to keep exactly the same water to cement ratio of the previous trials, because that is really paramount to maintain, and you can see here, the strength development of the elements. Additionally, what we can say is that in this case, even after a significant reduction of the water content, we are talking about 12 liters per cubic, we are anyway able to keep more or less the same number of cycles of the previous test, number one. That means a similar compactability of the concrete, and so similar energy needed in the plant to produce the elements. And you can see also here the shape of the curves, if we compare the number of cycles and the increase in terms of the density of the elements during the compaction process. I would say, I hope that the concept is clear enough for you, but anyway, I think that it will be self-explaining later on, when I will show you a couple of videos that were recorded during the field test directly at the production site with the MasterEase. So let's go here with a couple of examples of real tests carried out in the plant. Here we are talking about Hollowcore slabs production, and in the table you can find on the left the standard mix, that one that was commonly used by the customer at daily basis. And in the right part of the table you can find the optimized version of the mix with MasterEase. In this specific case, it was really possible to manage two different admixtures in the plant. So in the optimized version of the mix, we have decided to, I would say, add the MasterEase on top of the MasterCast product based on all technologies. And what we have done in the detail, in this case, we have reduced by 20 kg per cubic meter the cement content, and we have replaced it by volume with fine sand. Additionally, we have reduced by 8 liters per cubic the water, in order to keep, as already said, the same water to cement ratio that is paramount to maintain the same strength development of the reference mix. And here I would like to share you, as I already mentioned, a short video of the trials. And additionally, I would like to underline a couple of comments that were raised during the production. And it was observed by using MasterEase is also a nicer surface texture of the slab, so an improved aesthetics of the element. And also, it seems that by using MasterEase, especially in this case, the mix looked more robust, meaning that it was less sensitive against possible water content variation in the mix. And then we have another case history here. In this case, we are talking about small pre-stressed beams, and the approach was more or less the same as in the previous one. But in this case, since it was possible to manage just one admixture in the plant, we have fully substituted the MasterCast product with the MasterEase one. And again, more or less same approach. We have reduced in this case by 30 kg per cubic the cement content, replacing it by sand. We have reduced also by 12 liters per cubic the water, in order to keep again the same water to cement ratio. And of course, by doing that, we were able to keep exactly the same, I would say even better strength in this case, if compared to the reference mix. Here you can see another video of the test with the MasterEase in this plant. And a couple of remarks. As you can see, also the sensibility of the customers is different. In this case was mainly highlighted this sustainability approach. So the cement reduction, that means less CO2 emissions for sure. And it was really appreciated also, I would say, the capability of the machine to run smoothly, even after a significant reduction of the water content in the mix. So just to conclude, I would like to summarize a little bit what I have just shown to you. So the MasterEase technology really provide kind of superior rheological properties to the concrete, and it is really a door opener for a significant reduction of the water content also in Hollowcore production by using slip formers. That is, as I already said, in most of the cases not possible by using PCE-based admixtures. What we can provide through the water reduction approach and through the mix design optimization is also a kind of raw material cost saving. Here I did a kind of estimation. I have assumed more or less 20,000 cubic of concrete produced in a year for each casting machine. That means in the worst case, at least 400,000 kg of cement savings per year. That is, of course, something good in terms of cost reduction, but also in terms of sustainability. And this topic is, of course, getting more and more important day by day. And on top of that, I would underline also a couple of comments that were highlighted by our customer. That is this increase of the tolerance of the mix to water content variations that can help to reduce also the amount of waste, and this improved surface finishing of the elements. That's really all from my side. Thanks a lot for your kind attention, and of course, if you have questions or comments, please feel free to ask.
Thank you very much, Gaetano, for your presentation. Again, no questions from the audience. So, as I say, as we're running a little bit behind the schedule, we'll move on. But thank you once again for your interesting presentation.
Thanks to you.
Thank you. Right. So, allow me to introduce our last but not least, our third and final presenter, who is Nikolai Stephenson from StruSoft, where he's the head of new markets and precast. And Nikolai is going to be talking to you about how you can create, coordinate, and plan your precast and Hollowcore projects together from different locations, and how we can get everybody connected via the cloud. So over to you, Nikolai.
Thank you, Tom. Tom, can you just confirm if you see my screen with the presentation?
I do.
Perfect, perfect. Great. Yeah, so the raisin at the end of the sausage, directly translated as we say, the last person to go on here in Denmark. And I'll keep it short and to the point, or as much as I possibly can, of course. For those of you guys who are in Central Europe, we don't want to start digging into your lunch break, of course. So I have my presentation here just on the screen next to me, so that's why I might be looking a little bit to the side sometimes. But the title of it is Working from Home in Different Locations in 2021. And as you can see, I put some pictures of a cloud and like a small catchphrase, welcome to the cloud. So that's what the presentation is going to be about today, these things that you can work together with your colleagues, even if they're in different countries, different cities, or working from home, or wherever they might be, of course. So working from multiple locations, I just have a quick introduction first about some of the tools that we all know and use today. So, we have these very, very strong video conferencing and file sharing tools. And we can see that just today with us being here on GoToWebinar and doing the IPHA webcast here, of course. And in most of your businesses, tools like this are already implemented. And it might be tools like Google Drive, Microsoft Teams. I know we've had both in our company. And that's some tools that just make it really, really easy to collaborate together with your colleagues. And I don't want to advertise for these tools, but I just wanted to draw like a little bit of line of something that we're all very good at, and something that I think that the current pandemic situation has really sped up as well, especially in these times. Being online, being connected has never been more important than it is right now, and probably will continue to be in the future. But that's enough about other systems, and these things don't really concern Hollowcore that much, other than of course, all of our businesses, we're using some things like this with documents and so on. But what I want to do instead is I want to jump into a project workflow. Let's call it a project workflow in a precast project, or more specific, a Hollowcore project. Of course, the projects tend to be similar. It's the product that differ in this case here. So below, I've made a very, very simplified workflow. And of course, there's many, many actors in a project like this. It might be 10 times the amount of people that is here. But again, for the sake of the example, we have around 15 minutes here, 15 to 20 minutes. And just to keep it nice and tidy, we can do it like this. So in this case here, we have Ingrid, Peter, Hank, and Alan. And for those of you who still have coffee in your cups, you might notice that the first letters of these people's names are I, P, H, and A. So just for the honor of IPHA, I've given these people these names today. But Ingrid is a detailer. She's working from home in this case. Peter is a planner. He is at the office. Hank is a production foreman, and he is in the factory, which might not be located in the same place that the office is. Definitely, you have to walk in between at least. And then Alan, who is an actual truck driver. So not even an erection company, but the truck driver himself. And usually in a workflow, of course, I call it old-fashioned. You have something that Ingrid does something, sends it to Peter. Peter then looks at it, does whatever he needs to do, sends it to Hank, and so on until Alan gets his delivery note, of course. If something is wrong in some of the parts, so if they need someone to look at it again, of course, it goes backwards again. This is simplified a lot, of course, because, of course, Alan might need something from Ingrid, or Peter might need to talk with Alan, and so on. So there's a lot of arrows. So this again, you can have 10 times the amount of actors, you can have the 10 times the amount of arrows here. But the next step in this small example I'm running on, and this is the example I'll keep running through the whole presentation, of course, is what IT solutions do you have? Because the only thing that can facilitate that you're working from multiple locations, or there are two things. One is phones, and the other one is in general computers and smartphones, tablets, and so on. And usually available to these, they probably all have phones, but not necessarily do the need to use them. But we can see in the picture here that Ingrid, this picture in front of her, this is supposed to be a computer screen. Same with Peter. These two people, they're sitting with mainly their computers. When we get out to Hank, he might be sitting on a computer. He might have a screen in the factory that he's using, or he might be using only the phone. When we then get to Alan, he's driving around. So he's not carrying around a computer. Most of the time he isn't, at least. So the IT tools or the IT hardware that he has available for himself is basically a phone, maybe a tablet or an iPad or something like that, if he is really sophisticated here. But basically that's the tools that we'll be using in the example as well. And then again, this is still showing the old workflow with these arrows. So what is the difference then of working by sending emails to each other, or by sending things with mail to each other, like we did in before of faxes, is that we are going to have a database. Basically, what database means is just a base for the data. And data is everything, or could be everything. It could be files, it could be project information, it could be tables. And in the case of StruSoft here, of course, we make software. And this example, of course, revolves around our software. And that software is called Impact in this case here. So it says the Impact database. But the difference now here, and from where we were before, where we had these arrows, is that gone are the arrows, and you just have a line connecting into the database instead. And this is what makes it possible for these guys to work together. That every single time Peter does something, Alan does something, Hank does something, all the other actors can see it straight away. So it means that, for example, if Alan delivers the element, Ingrid will see the elements on her screen change color, and signal that they have actually been delivered on site. So if she needs to check up on something, she can follow it along with what Alan is doing as well. So that's what the database makes possible here. It doesn't have to be on the cloud, on the World Wide Web. It could be on a server at your company. And even if we're removing all these actors, if there's only one person, of course, you know, you can just have it installed on one PC or something like that. But the focus here, of course, is we have something that we can access from anywhere. And both the server local, as long as it has internet, or an actual cloud is okay for that. So what happens when you work through a common database? And this is just a small slide. I won't spend too much time on this slide here. But basically it means that we need to be able to get information from different places. And that's what this slide is all about here. You know, are you getting 3D models from different 3D modeling software? We of course have our own 3D model software. We have our good colleagues here at IPHA. Maybe some of you guys are attending today as well. You also have something, and we want to have these things, you know, put into that database. And then what did you think? Okay, I don't have 3D modeling software. What do I do then? Well, then you can still import information through Excel sheets or XML documents if you have a good IT guy, something like that. And the whole point is to bring it in the system. And a little bit differently than when we see many of our good colleagues do is that here we create a 3D model. But that 3D model, it's not a file. It's a representation of data that is in the database. So it's a representation of a lot of numbers and a lot of different tables and a lot of information in there. And the easiest way to compare it is like when you're playing a video game. The video game itself, you're running through the video game and it's creating the graphics for you. So the same point is here, that you know, you get into this planning system here and it's creating these graphics for you. You don't need any files on your computer. It just takes the data and translates it live on your computer to what's happening. And that's also what makes it possible that when Alan does something, he delivers some elements, then they turn up green or they turn up red on Ingrid or Hank's computer. But I'll actually get to what these guys are doing now on the next slide. So first of all, we have Ingrid. She's the detailer, she's the designer, she's the 3D modeler, whatever words we have for this. And here you're looking at this, you're thinking, okay, this is a 3D model. This is like a BIM model, some Hollowcore or something like that. It's actually not. This is again representation of what is in the database. So Ingrid, she makes a drawing, she makes a model, but this, what is happening on my screen right now, is actually coming from the database. So this is no file lying somewhere. This is just data being handled. And of course, as you can see here, I just put this in as a small erection sequence with a few floors, of course, with Hollowcores here, some simple Hollowcores. But you know, it's a little bit thinking of what is it actually that you're looking at. And in this case here, you're thinking you're looking at a drawing, but you're actually looking at you know, computerized data that it translates and makes it so that we as people can actually understand what's happening in a very, very visual way. You know, we can see everything that's going on here. So Ingrid does this automatically gets to Peter. And what Peter then starts to do, Jani, he talked about a little bit, you know, planning the casts, optimizing these things. He's still connected. He's connected to the same database as Ingrid. So as soon as she does something, he can see what's happening. And she checks up, okay, these elements are green. He will immediately see the elements are green. What does that mean to him? It means that he can actually start to plan them for production. So that's what he does in this case. And in this example I have here with these few actors, Peter, he's also the one who's doing the truckloads, so the transport, so the stacks that go out to storage and go out to site later on. But again, it's the exact same model and the exact same system. And here you can see a very good example of colors. You know, it changing colors depending on what it is you're doing with it. So this is showing stack colors. And that actually means that when Ingrid is looking at this, she can also see these stack colors. And again, the whole thing is about this connection here. But now Peter, he's finished planning. He leaves over to Hank. Hank, he looks at the planning, of course. Hank, he might have a screen in the production hall. He might have a laptop, or still, we are working in the cloud. It doesn't mean we necessarily have to go paperless. So of course he can print out something to look at if that's what he prefers. When he then starts to work through, or when the factory then starts to work through, there are some manual things that we have to do. You know, we have to make element controls. We have to check the measurements. Are they okay? And these different things. We have to do some inspections to check is the quality like it should be. Are there some points, corners broken off that needs repairing or something like that? And all of this, Hank, of course, can do. And that's when it gets into being his mobile phone instead of his computer. And I have a very short video here of Hank doing something. So I'll be limited a little bit by the pandemic. So this is the recording of a mobile phone shown on a computer screen. But basically it shows the same thing as what you do on the mobile phone as well. So this is just a live recording of a mobile phone. I'll just press play here. And this is doing an inspection on an element. So if you follow this here, you can see, okay, we're doing some controls. Now we want to inspect the element. As we click inspect, we're prompted to take a picture. And here, now this is a wall in an apartment, of course. We're locked down pretty tightly, at least us office guys here right now. But it's completely the same if it's a precast element, of course. So just taking 2 pictures for good measure, clicking save, and it'll be in the system together with everything else. The only difference is that this comes from the mobile phone instead. And in this thing here, we see all of these different controls and inspections being done in all the projects that the factory is actually doing right now. Everything comes through, the pictures come through. Even again, these pictures, they don't come through as files. Our developer, one of our lead developers, he told me when I asked him what the file format is, he said none. It is modern, he said. Basically means that it's binary data, and binary means bunch of ones and zeros. So again, it's database information that creates a picture of you. It's not like an actual picture actually, but that is what we as people see. So skipping on to Alan. What's Alan doing then? Well, he's driving the truckload. And what's happening when he delivers it on site? Well, he needs to let someone know that he's actually delivered it. He has a mobile phone in his pocket. And as long as he has power on, battery on the phone, well, what he can do is he can look up the elements, or if there's a piece of paper with a tag on, he can scan them. And what he does is he press, these elements are now delivered. And again, the same thing happens for all of the other actors. When they're looking at these models, it changes color. So they can see, okay, now these are actually delivered. They can also see who delivered them, when, and all of these things here. So again, it's about being connected, being up to date all the time. And this is just an image of the tools. You know, he may have some sort of tablet or may have some sort of phone here. So I don't want to spend too much more time. So just summing up a little bit here, you know, when working on this shared database in the cloud, it can be, if we had a good internet connection, it can be almost just like working in the same office. Or even if I take that statement a little bit further, you know, it's almost like you have the power of 10 people in one person, in one computer, or in one it's a database in this case. So you have all these people working at the same time together, seeing everything that each other is doing and being able to coordinate very quickly what they need to do. So of course, these tools, these workflows, I haven't mentioned the tools too much, but basically some software tools that we make here at StruSoft, called Impact Design for the modeling, Impact Production for some planning, Impact Go for the mobile apps, and Impact Project for project management. And we make a lot of software like this, of course. If you guys are more interested in it, I know when you're talking about the cloud, when you're talking about internet, it gets a little bit technical, you know. But at least we're here to help you, here to make it seem easier. And as I know, IPHA, of course, with all of our friends from here, we come from different areas, we come from different countries, very international organization. And I just put in pictures of a few of my colleagues here. You know, are you from India? You can contact my colleague Sandeep if you want to know more. Are you from Greece? You can contact Thomas, who's born in Greece. Are you from Sweden? You can talk with Peter, Denmark, me, UK, our very own Paul Tate, and so on. But yeah, and you can check out more at strusoft.com/impact if you want to know more. And basically, that was what I had. And I'll just end up here with this beautiful picture of a sun rising over some Hollowcore elements. Yeah, that's it. If you have any questions, now is the time.
Thank you, Nikolai. That's a nice picture to end it on, indeed. We don't have any questions that I can see for you here. We did miss one question that just came in slightly late for Gaetano, so I'll from Paolo, so I'll email that across to Gaetano so he can answer that for you, Paolo. But yeah, as I say, Nikolai, no questions for you. But if you do have questions for any of our presenters today, I'll be sending out further information with their contact details as well. And you'll be able to see a recording of the webinar as well in due course via the IPHA website. So if there's anything that's been useful today that you want to share with your colleagues, you can do that as well. So yeah, thank you very much, Nikolai. So that just leaves me to hand back over to Carsten to say his final words.
Yes, thank you. I think this was really another very successful and interesting IPHA webinar. Thank you very much to Elematic, to MBCC and StruSoft for your cooperation during the planning process and for your interesting presentations. And thank you to all who joined this webinar. We plan the next webinar to be on the 12th of March. Participating member companies will be Prinsuland, Trimble, and Compilift. We hope that you will all sign up again and connect again in March. So thank you very much, and goodbye from me.